Beginning about 3,000 years ago, the Polynesians set out from what is today the island of Taiwan on a migration that would in the end take them to the atolls and archipelagos from New Zealand to Hawaii. They did it in small open canoes with only the sun and stars to guide them.
It's amazing what our ancestors accomplished given the kinds of resources that were available. These are highly intelligent, motivated people that were highly resourceful. And the result of that, the example of that, and the evidence of that is the fact that they found all these islands.
Kulepa Babayan is a traditional navigator with the Polynesian Voyaging Society.
Just if you can steer towards this kukui
They're Hawaiians who sail using the same techniques that brought their ancestors to Hawaii more than 1,000 years ago.
The sun is about 20 degrees north of east. That's where it's coming out of the horizon. So my hand is about 20 degrees wide. Yeah. So east is actually not where the sun's coming out, but where my fingertips are over here. If east is on our beam, then we're gonna be going north, yeah?
Sunrise was key to Polynesian navigating. They'd orientate everything to where the sun rose in the morning.
That's your best navigational clue at sunrise. As that sun is rising, well, I'm scanning the horizon, I see these swells out here. If you understand where the swells came from in relationship to where the sun rose, then you can navigate in the harder part of the day when the sun is really high.
At night, these ancient voyagers used stars to guide them across the featureless ocean. There were stars and constellations that they knew of, and they tracked them across the sky, just like the sun.
It tells you that these are great explorers, that they were calculating and they were able to identify the clues that led them to these islands. They were just driven by great curiosity about the world they lived in.
It's what got these people across Earth's largest ocean, and they did it 300 years before the first European. That may all sound like ancient history, but techniques used by the Polynesians and all the mariners who followed are still being used today. The only difference is that we're exploring the surface of a different world. For our ancestors, the skies were like a survival guide. They guided them on voyages across Earth and opened our planet to exploration. And today, the skies are helping us explore the surface of other worlds.
The stars have been the foundation of navigation since people first looked up, and we use it during Apollo.
Even though they had computers and sophisticated navigational devices, the lunar astronauts relied on the stars to guide them on their 400,000-kilometer voyage to the moon.
I can't remember how many star sightings we might have taken, but there's certainly no question that you are dependent upon the stars, you're dependent upon this machine, which is oriented with respect to the stars.
The electronic navigation system couldn't read all the tiny changes in course, which on such a long journey could have had enormous consequences.
If you're shooting a rifle and the target's only 50 feet away, you can probably get somewhere near the bullseye. But if it's out there, half a mile away and you're trying to use a telescope, I mean, a very, very slight change is going to make a huge difference way out there.
Being a marksman is a lot like being a lunar astronaut. We're both shooting at targets very far away. A little bit of difference at this end makes a lot of difference at that end. And if I'm off on my trigger press, on my breathing, by just a little bit, I can completely miss the target. Let me show you what I mean. Well, let's go see how I did. Now, I was shooting from 35 yards away, and as you can see, my bullet impacts are pretty much in the center of the target, except I've got one that's off to the left just a little bit. That was because of something that I did that wasn't quite as perfect as the other two. And those little mistakes magnify themselves at distance. So what would happen if we tripled the distance to the target? Let's go find out. You can see how at 35 yards, the bullets are almost touching. Well, we triple the distance and the shots start to spread out. Now I'm aiming at the same spot. I'm holding right at the dead center of the blue circle and I'm trying to hit the center. But those tiny little imperfections are causing errors the farther I get away. Now you can see why those astronauts had to constantly readjust their navigation, because a little error makes a big difference 250,000 miles away.
To stay on course, the astronauts used the same tool navigators have used for hundreds of years, a sextant.
What the sextant does is it basically lets you make very accurate measurements about the angular separation between objects in the sky and the horizon. And by taking a series of these measurements, measuring certain stars and where they are above the horizon, and comparing that to carefully tabulated tables, you would be able to basically look up your geographic location based on the location of the stars in the sky.
The sextant has been used by navigators ever since its invention in the 1600s.
The way you would do it, actually, in Apollo is you would essentially tell the computer, okay, hey, point the sextant at some particular star. Point the sextant at Canopus. And it thinks it's right, so it knows where Canopus is, and it goes, it points the sextant in that direction. Now you look through the sextant, and here's the crosshairs, and Canopus is really over here instead of being at the middle of the crosshairs. So what you do is you move the crosshairs up, or you move Canopus down into the crosshairs, and you mark. And you say, that's where it really is, dummy.
The Apollo astronauts would take several star sightings a day to correct their course. Without the sextant, they might never have made it.
Anybody who has spent time with the stars has forever friends up there. I mean, you know that when you look up again, there they're going to be. You can count on them.
That's as true now as it was back during the days of Apollo. Since touching down on Mars in 2004, the Mars rovers have been wandering the dusty surface, probing the mysteries of the red planet. And mission scientists have used the sun to tell these robots where to go.
You don't want to fall into a crater. You don't want to bump into rocks. You need to know exactly which direction you're going. And so it's really important that we know where the sun is.
Using methods similar to the ancient Polynesians thousands of years ago, scientists take sightings of the sun and use them to remotely drive the rovers to explore the surface of Mars. Then they use the sun to send all that data back to Earth.
The rover needs to know where it can look in the sky to find the Earth. So to do that, it looks for the sun.
The trajectory of our evolution, from nomadic hunters to space explorers, was guided by the stars. Its patterns and cycles pushed on a course that would lead to everything we know and enjoy today.
We humans are simply asking the same questions, maybe in a slightly more sophisticated way, but we're trying to understand our spiritual and scientific place in the universe.
Astronomy prompts wonder. Wonder prompts the quest to develop accurate, more accurate descriptions of nature. More accurate descriptions of nature are a tool for survival.
In the known universe, the skies matter. Without them guiding us on a journey from prehistory into civilization, we would never have known so much about our planet, the universe, and our place within it.
Astronomy is not a luxury, it's a necessity, and we still use it in different ways, but we use it as energetically, as emphatically as our ancestors ever did.
Who knows where the stars will take us next? There are questions still remaining, and the chances are the skies will once again help us to find answers.